My dear students, today's topic is Nuclei 4 and which deals with your the radioactivity of your the basics about your the nuclear physics. On your the previous 3 episodes we have discussed about the fundamentals regarding your the nuclear physics in your the Nuclei 1, where we discussed the nomenclature and your the notification about your the nuclear terms, then the isomerisms, isobar, isotope, which are the classification of your the nuclei. Then in the Nuclei 2, we discussed about the different types of its the intrinsic properties like the size, shape, its density, its volume, and in your the nuclei of your the 3, we discussed about what about your the mass defect, binding energy per nucleons, and your the stability, or that is called your the stability belt. Are you prepared with your the 3 previous episodes? Now take your the pen and paper, remain your the calm and quiet and put attention what we are discussing. So today's discussions, it deals with your the nuclei of your the part 4, in which we will discuss the discovery of the alpha, beta and your the gamma. Next, the law of radioactivity, half life, relation of the half life and your the decay constant. So if we will go for your the binding energy, as we know from your the Einstein's mass energy formula in 1905, Einstein given mass energy formula. And in the binding energy we have written E is equals to del m c square. So when I have written E is equals to del m c square, you may be in the dilemma. So how that E is equals to del m c square being the developed? Suppose this is your the path on which we have taken a body of your the rest mass of your the m0. If some force being your the applied, we discussed, then which mass will be the more? Either the mass at its the stationary position or the mass is in the motion, that we discussed in the Nuclei 3, and we observed that when the mass is in the motion, then at that case that will be your the more heavier than that of the body at the rest. So when it is moving, it must move with the some energy, and due to the motion, that energy is your the kinetic energy. But that kinetic energy will produce here the some mass, and that mass is the very negligible one. Therefore we are neglecting, but actually the mass which it possesses earlier as your the m0, when it is in the motion, that m0 is gradually decreases, and if that mass is your the m0 mass in motion, m0 mass at rest, m0 mass in motion, then these two mass are related, and you know that very well that m is equals to m0 by root over of 1 minus v square by c square, which is derived from your the relativity. From your the relativity chapter, you will clear about this one. Relativity, you will get m is equals to m0 by root over of 1 minus v square by c square. So now we will go by taking this relation to find E is equals to your the del m c square, where del m is nothing but this is your the mass defect, as we discussed in earlier class. Mass defect, that means the defect in the mass, and that defect in the mass means the mass of the nucleus and the mass of its the constituent particles which is the nucleons. If the constituent particles mass to be taken together and the mass of the whole nucleus to be observed, then there is a difference. So, when some force being applied and it is in the motion with some speed of the v, then it will possess its the momentum, and we know that force is equals to how much? dp by the dt. Rate of change of momentum is the applied force, and this is equals to d by dt of the p. P is equals to momentum. Momentum is equals to the mv, mass into its the speed. So, that though it is in the speed which mass it contains, that is the m, but at the rest the mass is the m0. Though its speed is v, therefore its mass we have taken is the m, which we have written m is the mass in motion, means when it has its the speed. And this mass and the speed, they two be the variables. So, it is the product of the two. So, if you take its the differentiation, then that m of the dv by the dt plus v of the dm by the dt, that is equals to the f. Let us take that is equals to the equation 1. And if this is equals to the f, due to the force the body is in the motion, it will make some work, and that work will produce the energy. And if you will take a very small interval of 1, then the small work done is equals to the small energy. So, this is equals to dw is equals to de is equals to the f of the dx. Means suppose from here to here it cover a small displacement of the dx. Due to the application of the force F, the work which is done, that is equals to the dw. dw is equals to the de. de is equals to the f dx, because w is equals to the fs, you know, and the real value is the fs cos theta. Theta is the angle between the force and the displacement. The force is applied in which direction? The displacement is also taking place on the same direction. Therefore, this angle theta is equals to the 0. So, cos 0 is equals to the 1. So, w is equals to fs, and here the small work done. Therefore, this is the dw, and that dw will be the energy de, because the work is nothing but it is the energy, and de is equals to the f dx. And the value of the f is equals to the this one from equation 1. Let us put that one. So, m of dv by dt plus v of dm by dt of here the dx. Are you clear, my students? Originally the body has here the mass, that mass is here the m0, some force being here the applied, due to which its displacement taking place, that is equals to the dx. Due to that dx some work is done, the work is nothing but the energy, small work done dw is equals to the small energy de, that is equals to the f into dx, and that f is equals to the rate of change of momentum. Momentum is equals to the mv, mass is here the variable and v is here the variable. But you know earlier that the mass will never to be the change, but from the relativity the mass is not here the constant, it is here the variable one. Therefore, this mass is a variable and the v is the variable. But most of the students, they are taking that m is here the mass and the mass is the constant, that will comes out only, that is the dv by here the dt, and if that dv by here the dt, that is the acceleration. So, mass into acceleration is equals to the force. But here the m is the variable, v is the variable, product of the two. So, product of the two means the first derivative of the second plus second derivative of the first. Now, put that value of the f is here, and this will be, if rearrange, m of dx by here the dt of here the dv. This dx is multiplied. So, this is dv into dx. dx by dt I have taken into the one part, and dv will remain as such. Similarly, this is equals to v dx by here the dt of here the dm. This dx is the multiplied. So, dx by dt is nothing but that is equals to here the speed, and that is equals to the v of here the dv plus v. This dx by dv is equals to here the v of here the dm, that is equals to mv dv plus v square dm, that is equals to your the dE. Let us take this is equals to your the equation 2. So, if that is the equation 2, from this we know that m is equals to m0 by root over of 1 minus v square by c square. So, if you make square, making square of this one, then m square is equals to m0 square by 1 minus v square by c square. If the root over is there, then we have to give in the square one. So, if we make the direct square, then m square is equals to this one. So, this is equals to m0 square by c square minus v square by the c square. The LCM is the c square minus v square by the c square. This c square will go up. So, that is equals to m0 square c square by the m0 square, this c square is go up, c square minus v square is equals to the m square. So, if we make the cross multiplication, then this is equals to m square c square minus m square v square is equals to m0 square c square. Making the cross multiplication, m square c square minus m square v square is equals to m0 square c square. So, if we differentiate both sides, now differentiating both sides. When we will differentiate both sides, you see m is your the motion, that is the mass in motion, that is the variable. This is the variable, this is the constant. This is the variable, this is also variable. But m0 is your the constant, c is your the speed of the light, that is your the constant. So, here your c square is your the constant. So, m square will be your the 2m dm. Then this is equals to your the minus v square m square v square, both are your the variables. Therefore, minus of your the, if you will make your the first to be your the differentiate this, then 2m dm of a v square, then plus m square is your the constant, second function comes out, then v square to be differentiated, to v dv is equals to your the 0. Sir, why this is equal to 0? Because m0 is the mass at rest, which is the constant one. C is the speed of the light, that is the constant one. So, whole one is the constant, its derivative is equals to 0. You see 2 is your the common. Then this is your the c that is equals to your the c square. Here is the m, here is the m, here is the m is your the cancel. So, now this is equals to your the c square, then 2m is the cancel dm, then minus 2m is the cancel, then dm v square, then this is equals to minus of here the m v dv is equals to the 0. Are you clear? This implies c square dm is equals to dm of v square plus mv dv. You see mv dv plus v square dm, v square dm mv dv is equals to the c square dm. Now, put this value in equation 2. If this is equals to the equation 3, now putting the equation 3 in the equation 2. So, this will give you dE is equals to mv dv plus v square dm plus v square dm is equals to the c square dm. Now, integrating both sides. Now, integrating both sides. So, if we integrate this one, integration of dE is equals to integration of c square dm. So, in the integration you have to put the limit. This is the lower limit, this is the upper limit. This lower limit is the initially the body was at rest, its energy is the 0. When it is in the motion, let its the energy is the kinetic energy, energy is the kinetic energy, so we have written it is the Ek. And here the limit will be given for your the integrand part. Which one is the integrand part? The mass. When the energy at the 0, the mass at that position is its the rest mass, that is the m0, and when it is the Ek, that is in the motion, and that is equals to your the m. So this implies dE with the integration, that will give you the E plus some constant with the limit 0 to Ek, and this is equals to the c square constant comes out because the velocity speed of the light, then dm integration will be your the m plus some constant with the limit m0 to your the m. So this shows if you will put the limit, how you will put the limit? First you have to put the upper limit, then you have to put the lower limit, and both to be subtracted. The upper limit will be your the Ek plus c minus lower limit is the 0, 0 plus c is equals to this c square. The upper limit is the m, instead of the m is the m, so m plus c, then is the lower limit is the m0, so m0 plus c, and that to be the subtracted means the minus. So this is equals to Ek plus c minus c is equals to c square of the m plus c minus m0 minus c. You see chi means c cancel. So this implies Ek is equals to c square of m minus m0. So what is this m minus m0? We have written that is your the delta m, means your the mass defect. This is the mass in motion, this is the mass at the rest. For the same body, the body is the same, but their mass is the different. Therefore that mass, as we know, that is your the mass defect. So this m minus m0 is equals to your the del m, and this is your the c square. So this Ek is equals to your the total energy E. So E is equals to your the del m c square, which is the very important relation from your the Einstein's mass energy formula. We are getting that one in the year 1905. We came to know E is equals to del m c square. Del m is your the mass defect and c is your the speed of the light. From that you can write del m is equals to your the E by your the c square. But though this c is the velocity of the light is very much its magnitude, and its the square will be your the 2 more, therefore this factor can be neglected. So E and your the del m, that to be considered to be your the equivalent. Therefore this relation is known as your the mass energy equivalent. Hence we came to a conclusion that the mass is nothing but that is the part of the matter where the total energy being here the exhibited. Suppose from a mass, if some energy to be or the losing or some energy to be or the gaining, then according to that we will say that that mass factor to be or the increasing or your the decreasing. Taking these factors into your the account, a new concept being your the developed, which is called your the radioactivity. And in your the radioactivity we will came to know that from that factor of your the nuclear stability. So in the nuclear stability we came to know that if the neutron and the proton ratio will satisfy for a particular ratio value, then they will satisfy a belt which we discussed in your the last class. So my dear students, have you taken its the note? Okay. So now I can erase it. A, B, C, D, E. So next we will go for the radioactivity, which deals with the inner molecular property of your the nucleus. So that is your the radioactivity. Radioactivity means it is one type of the activity, given by your the elements. So what elements? Among 1500 elements, discovered so far only 260 of them are stable. 260 of them are the stable. So, those who are the stable, they will satisfy the ratio of your the n by p, which is either nearly equals to your the 1 or n by p greater of the 1 or the less equals to your the 1.6. We discussed in your the nuclear stability belt graph. So, this is your the stable one. So, what happens for the rest one? The rest are not your the stable. So, when the rests are not stable, means the n and your the p ratios are not satisfying to that conditions. So, at that case, it observed that some rays like alpha, beta, alpha or beta and gamma being emitted. So, alpha, beta and gamma, alpha or beta, there is a term or, means either alpha to be the emit or beta to be the emit, means this instability, if you will subtract 260 from your the 1500, then the rest are, suppose that is your the 40, then this is equals to your the 2, that means 1240 elements there are the unstable. So, if they are the unstable, they wants to be or the stable, or they creates to make it them to be or the stable. When the unstable elements gains to be stable, they emit certain alpha, beta and gamma rays, and this is your the discovered first by your the Becquerel. By your the Becquerel in probably 1896. In 1896, while he doing a experiment of your the fluorescence on your the fluorescence, he found that some of the rays being your the affected towards your the photographic plate, and it being came here the accidentally. Accidentally means he never thought that such thing to be the happen, but that to be the happen immediately, therefore it is called the accidentally. So, what happens? Suppose he taken some uranium and that is coated with here the black paper, and over that black near to the black paper some silver slit being your the taken, and after the silver slit, this is your the photographic plate. Photographic plate. Photographic plate. So, it observed that from the uranium of your the 238, some rays are passing, overcoming through your the black paper. This is the black paper, through the black paper, and it is penetrating through this one. After its the penetration, it comes towards your the photographic plate, and in that photographic plate, some black spots being your the formed. So, when these black spots being of the form, someone thought that some ray must be your the affecting towards your the photographic plate, but actually some rays to be or the emit, that was not thought by your the Becquerel. So, therefore, such type of the rays are also known as your the Becquerel rays. Becquerel rays. and that becquerel rays of your the three types. One is your the alpha, one is the beta, and your one is the gamma. Not only by your the becquerel, the other persons like your the Curie family. So, for your the Curie family, they also came to know in your the 1897 to your the 1903, the Marie Curie and your the Pierre Curie, and their family till today they have a record in your the Guinness book, because that family only achieved or they have obtained the Nobel prizes from a family in your the more times. So, that Marie and the Pierre Curie, they mostly belongs to your the Poland, therefore, they are known as the Polish, and the Polish names they developed your the two elements, one is your the polonium, one is your the radium. From the polonium and the radium also the same factors, means your the some radiations are going on. Therefore, radioactivity was found to be unaffected by your the chemical and the physical testing. Means, if this is your the this type of the process, that is your the nuclear process. This is your the nuclear process, because inside from the nucleus only this being happens. But there is another process is there which you know, that is the chemical process. Chemical process. In the chemical process also some changes are being happens, but that chemical processes they being your the changed by the external conditions. Suppose you increase the temperature or you will decrease the temperature, you increase the pressure or decrease the pressure, means by varying the pressure and temperature, this chemical process to be your the changed. But this nuclear process which is happening through your the uranium or your the polonium or your the rhodium, so they are not your the any change through your the outermost conditions like your the pressure and your the temperature. So, they are independent of that one, and that radiation will go on continue till the number of the nuclei particles contains through them. So, the nuclear process and your the chemical process. In the chemical process, there will be the change when the pressure and the temperature to be the vary, but for your the nuclear process, there is no change in its the effect. So, this is your the developed by your the becquerel and your the Marie Curie and your the Pierre Curie, and later also some other scientists like your the Rutherford. He also given that the same process to be or the happens, and according to your the Rutherford, he also provided there are the three types of the particles or rays. One is your the alpha particle, beta particle, and your the gamma particle. And these gamma particles in sometimes they also known as the gamma rays, because it contains your the no mass or your the no charge. So, according to the Rutherford, becquerel and Marie Curie and Pierre Curie, all they show that there are the three types of the particles. So, if we will go for your the experimental demonstration, suppose this is your the a lead cavity which is the very heavier one, and some radioactive substance being taken, and we have created an electric field. Suppose this is your the negative end, this is your the positive end, and from this radioactive substance some rays to be are the going and some rays are here the going likewise. So, though this is your the negative terminal, though this is your the positive terminal, it obtained that some rays are coming towards your the negative terminal. Those who are coming towards the negative terminal, it is quite clear that they must be your the positive in nature. and the rays which are coming towards the positive means they are your the negative in nature. And those who are going as your the undeviated, they have your the no charge, means they are going straight. So those who are coming to the negative, they are positive in nature, means they are the positive charge. They are known as your the alpha particle. And those who are coming towards the positive plate, means they are the negative in nature, they are your the beta particle. So this type of the demonstration given by your the Rutherford, and from this we clear that when some radioactive means your the unstable nuclei is placed, it try to obtain its the stability by losing your the some of its the energies in the form of your the some rays, means that is your the invisible rays. Therefore, that type of the rays will have its the different natures. So this is about your the discovery of your the radioactivity. So next, if we will go for your the individual particles nature, let us now go for your the alpha decay. So if we will go for your the alpha decay, means this alpha particle comes out, means the alpha decay is taking place. Decay. So this term of the decay means here the losing, that is known as the decay, means alpha is losing from a nucleus. Suppose the nucleus is your the X, and as we know that for its the representation we have given likewise, means X is your the element which has its the atomic number of the Z, means the number of protons is there, and this is your the A, means this is its the mass number of proton and your the neutron. From this, when some alpha to be your the disintegrate, if that alpha will go, then it will give you a new nucleus. That alpha means that is your, you see this is the alpha, means this is the positive in nature, and that alpha which is coming out, that is your the helium like in structure. So for the helium, that is your the 2 4. So this is the He of your the 2 4. But though this is the nuclear process, in that nuclear process we know that it will satisfy the conservation of your the charges. So if this is the Z, this is your the 2, then this is equals to your the Z minus 2. Though this is the A, this is your the 4, and here it will your the A minus 4, because A minus 4 plus 4 is equals to your the A, Z minus 2 plus 2 is equals to your the Z. So in this case, this is known as your the parent nuclei, and this is your the daughter nuclei. This is your the daughter nuclei. So the parent nuclei now converted to your the daughter nuclei, and if this daughter nuclei still it is your the unstable, it will lose your the some particles to try to become its the stability. So in this case, it will lose some amount of your the energy. So if we take for your the for example of the uranium 92 238 and some alpha to be your the emit, then that will give you the thorium 90 with 234 plus He24 plus some energy. You see 90 plus 2 is the 92, 234 plus 4 is equals to the 238. The question comes, sir, why this uranium 92 to 38 now it provides your the thorium, means this is your the unstable, it try to maintain its the stability. As we discussed earlier, if the neutron and the proton numbers to be are the plotted, and a nuclear stability graph will be maintained, and this nuclear stability graph for certain one, this will go up to your the A value, means the number of the protons value to be your the 20, and beyond that they are your the stability belt. So, this is your the stability belt as we discussed in your the nuclei 3. So, from your the 0 up to your the A value up to your the 20, then this n by your the p is nearly equals to your the 1. And if the some elements are there or the nucleus are there whose n by p is not equals to your the 1 or never satisfying the points which is to be lie over this one, then what will happen for them? Means suppose the nuclei are lying in this side. So, what it indicates? The neutron by protons are your the less than that of the stability. And those who are above this one, the neutron by proton ratio are your the more to that one. So, when it is less to that one, they to be your the come and they to be your the gain some of the energy to come to your the stability line. And those who are beyond the stability line, they will try to lose some energy and to come to your the stability line. So, the dot which are shown in the figure, they are your the unstable nucleus. So, to find that instability nuclei, let us now discuss for here what is happening. This 92 is your the proton. Then what is the number of the neutron? This 238 minus of your the 92. So, 238 means this is equals to 6, that is equals to 146. So, n by p is equals to 146 by your the 92. And if you will come here for the daughter nuclei, here n is equals to your the 40. N means your the your p is equals to your the 40, 90. P is equals to your the 90. P means your the proton. This is your the Z, that is the 90. Then what will your the n? 234 minus 90. So, 234 minus 90, 4 minus 0, 4, and this is equals to your the 14, 144. So, this n by p is equals to 144 by your the 90. So, this 146 by your the 92, that is nearly 1.58, and this is your the nearly 1.6. Just imagine 1.58, 1.58 for the uranium 92 235. When it is losing your the alpha, this n by p becomes your the 1.6. So, 1.58 to 1.6 means this is more than that of the 1.58. When it is more than means, suppose out of them this is your the uranium 1, which is your the unstable for your the 238. And if this is the uranium, by losing the alpha, its 1.58 ratio value now becomes your the 1.6, means it is going up. Means this nuclei after losing the alpha, it comes towards your the stability belt. And then after losing your the alpha particle, another one, it will come towards your the stability belt, and when it will come over your the stability belt, there will be the no losing of your the any type of the particle from it. Therefore, the such type of your the alpha ray which is happening, that is your the to the right of your the stability belt. So, this is your the nature of your the alpha particle, and this alpha particle is your the positive in nature, like your the helium of the 2 charge and your the 4 mass. So, if we go for its the detailing, you can see on your the screen that there is another example we have taken, that is your the radium with your the randon. When the radium of your the 88 and 226 and alpha ray to be the taken place, then it will becomes your the Rn, that is your the radon of your the 86 with your the 222, and here also the vast amount of the energy being your the comes out. Then this alpha decay occurs because the strong nuclear force is unable to hold very large nuclei together. The electrical repulsion between the protons of the nucleus pushes apart and can act over such a larger distance than the strong nuclear force. Since the strong nuclear force can only act on the particle directly besides each other, the electrical repulsion overcomes the strong nuclear force and the pushes the nucleons apart. Next we will go for the beta decay. So, beta decay, this is about your the alpha decay. Have you taken the note? Can I erase it? Okay. A, B, C, D, E. So, alpha particle, next we will go for its the second type of the ray, that is your the beta particle. Next one here the beta decay. So, as we know that this beta is your the electron particle. This is a electron particle. The question comes, sir, though we have taken a nucleus inside which the proton neutrons are there, the nucleus is your the positive in nature. This is your the positive, nucleus is your the positive charge. Though the nucleus is the positive, from it some emissions are going on, and that emissions from the positive, how sir it becomes the electron? Electron is the negative in charge. But we have taken the nucleus because we are discussing about the nuclear physics. This is your the nucleus. For the nucleus, sir, how the negative charge particle will come? And that is your the most interesting one. And in this case, it happens that the neutrons which is present inside your the nucleus, that neutron converted to proton. The neutron converted to the proton, but the neutron is your the neutral, the proton is of your the positive charge. So, when this is the neutral becomes your the positive charge, but it to be satisfy the nuclear forces nature, means the charges to be the conserved, means suppose we have taken the neutron N01, this N01 will give you one proton. You see, this neutron is your the neutral, atomic number means your the electrons charge is your the 0. So, this is the 0. So, there is no charge. Now, it becomes your the proton. So, when the 0 charge becomes your the proton, what will happen? To maintain its the charge to be your the stability, there should be a negative charge. So, this positive charge was not there. Originally, the neutrons are converted to the proton. Neutron converted to proton. To maintain its the same charge, there will be a negative charge to be arise. So, this negative charge which is arise here, that is your the -1. Therefore, that is your the electron particle. And this type of the ray which is invisible, that is your the beta ray or the beta particle, we can say. This is your the theory behind your the beta decay. So, the beta decay is your the negative in charge and the mass is that of the electron. And for your the alpha decay we have taken, and if we go for the example of your the XZA, a beta decay, then this x will become the y, this is equals to the z plus 1 of your the a with your the e minus 1 0 plus of your the some types of your the energy which is called your the neutrino. Some neutrino to be developed with your the some energy, and this is the equation for your the beta decay. You see z, here it is the z plus 1 minus 1 plus 1 minus 1 cancel, z will be the z, then this is the a plus 0 is your a, here is the a. So, the mass and the charge on the left and the right will remain here the same, and these are the natures of your the beta decay. For beta decay, we have taken X is your the parent nuclei, this is the parent nuclei, not your the prananath, and this is your the daughter nuclei, that is not your the dayanidhi. So, this X will becomes your the Y. If we take for the particular example of your the carbon to your the nitrogen. Suppose you will take the carbon of the C6 with your the 12, or your the isotopes, suppose you will take that is the 14, with the nitrogen that is equals to your the 7 with your the 14. You see this is 6 now becomes the 7, but they to be the maintained there the numbers with your the atomic number and with is the mass number is remain same. So this is equals to your the -1 0 plus of your the some beta neutrino, and which is called your the anti-neutrino also said, with the emission of your the some energy, and this is the example for your the taking a particular elements. So for your the beta decay, it occurs the emission of an electron, or that emission of the electron is known as the beta particle. So no nucleus are your the loss, and the total number of the nucleus are to be the same in the daughter nuclei as in your the parent nucleus. With the loss of the electron, the nucleus must have an extra positive charge. So in this case, the number of the protons is your the 7, and which is your the nitrogen, as per our the example of your the carbon of C614 to your the nitrogen of 714. The electrons emitted in your the beta decay is not an the orbital electron. The electron is created in the nucleus itself. As I said, the new electron is created inside the nucleus. How it is created inside the nucleus? Because by taking one of the neutron, it converted to your the proton to maintain your the same charge nature, an electron to be your the created. One of the neutron changes into the proton, and in the process throw off on the electron. These particles we refer to as the beta particles, as not to be the confused then that of your the orbital electron. This is the most important one. The electron which is developed here, this electron is not the orbital electron, because this is only happens inside the nucleus, and that particular negative type of the electron which is created inside the nucleus, that has given a specific name, that is your the beta particle. So this beta decay will produce the neutrino with its the high energy gain, and this beta decay and the neutrino as we represent in your the example of your the C6 of your the 14, that of the N714, this is your the beta, this is your the neutrino with your the energy. So this is about your the beta decay of your the beta decay. So alpha is over, beta is over, next one comes your the gamma particle, and these gamma particles are purely, they are your the gamma rays. As per our the diagram we have seen that the alpha, beta and the gamma is going your the undeviated, means it has your the no charge, it is one type of your the wave, therefore this is also known as your the gamma wave. So how that wave being the developed without its the existence, that is purely depends upon its the exciting states. So when some energy being your the created in your the any energy level, suppose this is your the ground energy level and this is your the excited energy level, this is your the ground state, this is the excited state. Suppose this is your the nucleus, actually not your the nucleus, but we are considering here for the nucleus because they have the particles. Suppose one of the neutrino, one of the proton is your the shifted towards your the excited towards the state by gaining the energy, as we have seen that when some alpha or the beta being your the taken place. So we have written earlier alpha or beta and gamma, means this gamma is associated with alpha as well as the beta. Suppose some alpha to be emitted, alpha is emitted, the gamma is there. Some beta to be emitted, the gamma is there. Means if you take here the veg, the gamma is there, means suppose this is a desert. If you take here the non-veg, this is your the gamma, means that is your the desert. Suppose you will take here the suppose you will take the paratha, then the sweet is there. Suppose you will take here the simple rice, and then also here the sweet is there. So either alpha or the beta, means during the alpha and the beta, the energy is coming out. So due to gaining that energy, it being the excited to this one. So during, well, it will come to its excited within your the very few seconds, 10 to the power of minus 10 seconds, very few seconds, it again returns to your the ground state. So when it returns to the ground state, the energy through which it comes, that energy is known as your the photon. That energy is known as your the photon, means the gamma rays are coming in the form of the photon. Sir, how it is coming in the form of the photon? Suppose this is your the ground state energy, is your the En1, this is the excited energy, that is the En2. So there is a change of the energy, means En2 minus En1 is equals to your the h nu, and this h nu is nothing but the photon energy. From your the quantum idea, it came that it is your the photon energy, means the gamma rays are your the photons in your the shape. Therefore alpha, beta and your the gamma. That alpha, beta, gamma, when we discuss, if you will plot a tabular form for them, a tabular form. One is your the properties, then your the alpha, beta and your the gamma. The property number 1, suppose it is the nature. This is your the helium, this is your the electron, and this is your the electromagnetic wave. As we came to know, this is your the helium, like this is the electron, this is one. The second one, the mass. That mass of the helium, that means your the 4 AMU, means He24. So 4 is its the mass, so here the 4 AMU. This is your the 1/1837 AMU, and it has your the no mass. Then third, charge. This charge, that of your the electrons, that is equals to your the 2E, that of your the E, and it has your the no charge. Then fourth one is it's the penetrating ability. Penetrating ability. Penetrating means to penetrate, means to pass through. So this penetrating is your the very low, this is your the moderate, and this is your the high. The fifth one, ionization ability, that is your the high, this is your the moderate, this is your the low. Next is your the field nature. Field nature. This field nature is your the affected in electric and magnetic. This is also affected in electric and magnetic. This is your the undeflected. Means this can be, you will say, to be your the deflected. This is also the deflected. And your the most important one according to the present situation, that is your the coronavirus. So, coronavirus nature. In the coronavirus, you know that there is a alpha, beta and your the gamma also. This corona of your the alpha, that to be your the affected towards your the bats. This is your the COVID-19 today. The history being your the created in the world, COVID-19, that COVID-19 one type of the coronavirus of your the beta decay, and the gamma for your the dolphins and your the birds, dolphin and the birds, and the newly developed is your the delta 1. Delta 1, this is also towards your the bird and your the swan. So, this is your the delta of the coronavirus. So, this coronavirus one type of the property of your also the alpha, beta and your the gamma. So, with this we came to a conclusion that how a radioactive elements, the properties of the rays which to be the emitted, they are the alpha, beta and your the gamma rays, and they are detailing about it. After that we will discuss about your the laws of the radioactivity in the forthcoming episode. Be your the prepare for that one. Thank you very much.